Okay, so in our last video, you were starting to work with definite integrals, and you did it by counting boxes, this guy, and it was really annoying. So there's got to be a better way, and luckily there is. We're going to use trapezoids. It's still an estimate, but it's going to be easier than the counting boxes. So first of all, just a little reminder, area of a trapezoid is simply the average of the bases times the height, which is, and you usually see it this way. Our trapezoids are going to be on their side, so the quote height is actually that left to right width, but that's okay, we'll deal with it. So quick reminder there, that's what we need. So if you know this formula, you can do this, no big deal. So we're going to divide this just into 3 trapezoids. We are going to be looking at the area from x equals 1 to x equals 10. Our equation for this, in case you're curious, is y equals 6x minus 0.5x squared. So we're going to divide this into 3 equal width rectangles. I may have chosen things to be super convenient here. So I divide this into 3 strips. They happen to be 3 wide. And then I can even draw my trapezoids in just so we can take a look. So as you can see, the area of these 3 trapezoids combined, it's fairly close to the area of, underneath the curve between 1 and 10. It is in this case an underestimate because of those little bits that are sticking out. It's also possible for a trapezoid to overestimate in case that you have like something that's curved in the opposite direction. If we had more trapezoids here, it would be less of a misestimate. Is that a word? So what we need here, I'm going to go ahead and label my heights here. So this is the point, this height is at 5.5. When x is 4, the height is 16. When x is 7, the height is 17.5. And at x equals 10, the height is 10. I'm just putting these y values in because I want them to be convenient. Okay, so looking at our area here, so this first trapezoid, it's going to be half of the 2 heights, 5.5 and 16. And then times the width or the height of the trapezoid, which is 3. So that's my first trapezoid. Second trapezoid, half of the 2 heights averaged, we're averaging our 2 heights basically. So 1/2 times 16 plus 17.5, again times the width. And then plus our third trapezoid, half of 17.5 plus 10 times the height of this trapezoid or its width, which is 3. And I need to slide over, apologies. So this is kind of cumbersome, and I promise I'm going to make a point. Now looking at this, you can see that we have these 1/2s in all of the parts. We also have the 3 in all of these parts. I'm going to factor this 1/2 to the front, just because it's a nice place to put it. I'm going to factor the 3 out as well. I'm going to put it at the end though, just to keep it at the end the way the others are. So I'm left with still the same insides. So I have 5.5 plus 16, and then I have plus 16 plus 17.5 from my second trapezoid, plus from my third trapezoid, 17.5 plus 10. And then times that width of 3. I could have, of course, just chucked this into the calculator and found that it was 123.75, but I promise I'm building to something. So looking at this, you can see that we have a 16 and a 16 added together. We also have a 17.5 and a 17.5 added together, but also we have that 1/2 on the outside. So it's like, oh wait, 16 plus 16 times 1/2. Well, that's just the 16. And the same for that 17.5. So we have a shortcut we're building. So really what we have is half of the 5.5 plus the 16 and the 17.5, and then plus half of that 10, all of this multiplied by 3. It might seem a little silly to do all this, but there's a reason. I promise I have a reason. If we check this into a calculator, we get 123.75. It's actually fine to leave your answer just as it is, though. We could have left it actually as the top. So our big shortcut that's going to make our life easy, or easier, less bad, is what we have here is half of the first y value. And then we have plus the middle y values plus half of the last y value. I'm trying to make this squish for space. All of this multiplied by the width of the trapezoid, or the strip. We end up calling this guy delta x. That is the Greek letter delta. So our quick way of doing this, half the first y value, plus all the middle y values, plus half the last y value, all of that multiplied by the width of the trapezoid, the delta x. It saves a load of time. Of course, if we had, say, 9 trapezoids instead of 6, it would be much better results because you wouldn't have all those gaps, but close enough. Again, right now, we're just getting estimates. So later down the line, we're going to have this actually where it's an 100% perfect, exactly accurate answer, which is pretty cool. But that's not for a while.